And good morning. How's everyone? How is everyone doing this Friday? It's a good Friday. Happy Friday. Welcome. All right, so we're gonna do a quick warm up. Oh, what's that? Quick warm up. Gonna go back into Glitter, which we're calling Mitch. It's our Twitch tool. So what are we gonna do on Glitter today? I think we should get one of the other commands working or clean up one of the existing ones. I was thinking of having a little bit more bling. So let's see what we can do. All right, there's Twitch overlay. Let's go into following. We're going to go into sneaky. All right, so what happens with sneaky? This kind of fades in, goes away. I don't know. I don't quite like the little box around it. The box. I feel like it should be maybe changing color or something else. But instead of that, at the moment, let's see what else we can add to this, because I think it's what are we actually resizing here? Okay, we're resizing spatial. Let's add no, not caught. Add a child node. What are those called? The little emitter things. I'm drawing a blank. It's not emitter. It's I think it starts with an S. Particles. It ends with an S. All right. So we can add particles. Meshes have not been assigned to draw passes. The material to process the particles is not assigned, so no behavior is imprinted. Okay. We have to assign. Oh, there's a lot going on in here. Geometry, material, okay. All right, let's delete that from there. Delete nodes from there. We're going to put it at the top. I'm going to create a new one there. Particles. And I want you, we're going to go back to there, transform to y of 5. All right, what are we going to draw? It's going to be a -5. Y 5? No, -5. Because we're going down. -10. Oh. Oh, no, that should be 0. 0. Why is that negative? Okay. So we want that. Width is going to be, let's say, 10. Height, 10. Depth, 1. Okay. So we've got a little bounding box there. Great. It's not quite in the right spot. Let's go to front view. Because I want the top of this thing at, so with -5. There we go. Height, -10. Okay, because that should get us lined up with our camera. Process. Ooh. Particle material. Why not? So what was the other option? Shader material? I don't know what the difference is. Okay, now how do we add? Meshes have not been assigned to drawing passes. Drawing. Order. I don't see drawing passes in there. That's okay. Oh, here's drawing passes. Passes, pass one. Here we go. How about a quad mesh? Or literally making glitter. Ooh. We could do more than one, huh? All right, let's just keep it to one for now. Okay. Oh, that's not it. Don't want to do that. Stop it. Camera. So I want to play this scene. Okay, but that's not. It's not right. Because we need more time. Hmm. Transform, we're good. What else? Geometry? I don't think we need that. We've got drawing passes in. Oh, look at that. Ooh, emission shape, point. Oh, nice. Gravity, sure. Initial velocity, angular. Lifetime randomness. Sure, 0.1. Trail, divisor, size modifier. Lots of stuff in here to play with. All right, and then drawing. Local chords on. We're going to leave that one alone. What else do we have here? Then we've got. I don't know what one shot is. Let's see. Oh. What is pre-process? Let's look at the definition here. Okay. Speed scale. Explosiveness. Oh, I see. Is it like poof? Like you get everything. Let's do that. Boom, they're all there at the same time. Which means pre-process is not there. Randomness. Mission randomness ratio. I don't know. Let's say 0.5. Let's say 30. All right, lifetime should be 1 second. Oh, was it actually emitting there? I didn't see anything. I'm not seeing anything. Oh. Emission shape. Okay, what's the difference between process material and drawing? No, not that one. Draw passes. Pass 1. All right, let's pull up the docs. It's not that one. It's not the 2D one. Three D particles. What? Okay. Particles here. All right. What have we got here? 3D particles node used to create a variety of particle systems and effects. Particles features an emitter that generates some number of particles at a given rate. Use the process material property to add a particle material to configure particle appearance and behavior. Alternatively, you can add a shader material, which will be applied to all particles. Speaking is hard. This only works on the GLES3 renderer, which I think we're using. Yes, we are. Remember to update its visibility access align bounding box by selecting it, clicking the particles menu at the top of the 3D editor, then choosing generate visibility AABB. Oh. Selecting particles. Oh, look at that. Uh, there's not a lot in there. I'm not seeing any particles. Let's change the depth to just be 1. There we go. Huh. Oh. I mean, at the moment, I just want to see particles. Okay, tutorial. Methods. Okay, and this is just the regular documentation on this. Let's turn one shot off. Turn emitting on so we can see it. Nothing's going on in there. Okay. I do not want to see the environment. There we go. I guess we could leave the gizmos on. I just don't want to see the info. Okay. Geometry. Leaving that alone. Hmm. Gravity we have. Initial velocity. Nothing. Hue variation. Oh, that's neat. Yeah, it feels like, see, like right now it should be animating. We should be seeing particles, but we don't. Feels like it's this guy here. Draw passes. Okay, let's. Now there's something going on in there. Cube meshes. They're huge. Yeah, they're in there now. Okay. Let's do a plane mesh. Ah, now we see the planes. All right, so it's coming from that place right there. We can't see it yet. Geometry? No, where was it? Particle material. Here we go. So I was expecting this here. I was expecting them to be white. I don't see them as white. So, material override? Sure, shader material. Just something real quick. No, no, I don't want that. Clear. Let's go back. Still not white. You can see it's kind of going through there. You can probably pick up on the flickering here next to the cloud. No, wrong one again. Spatial material. Still nothing. That should just work. Okay. Let's go look at their tutorials. This looks like something out of the asset library. Oh. Ew. So they're saying that inside of this. Oh, okay. Shader type particles. Unique thing about particle shaders is that some built-in variables are saved across frames. Transform, color, and custom can all be accessed in the shader spatial shader of the mesh. Okay. Okay, but we're not using that. And that's neat. Using a particle material, you can make fish behavior as simple or as complex as you like. In this tutorial, we only set velocity. Okay, that was the entirety of the tutorial. And most of this is just about, let's see, this isn't, yeah, this is a shader. More shader. We don't want to make a shader. Okay. Go to particles node. Then under draw passes, set the particles draw pass 1 to your mesh. Okay, let's create a mesh. First, we'll delete that. Delete node. Yes. Bye-bye. Particles. Draw passes. Plane mesh is going to be fine for us. It's going to be 1 by 1's too big. Let's do 0.1, 0.1. Okay. Then under process material, create a new shader material. But we don't want a shader material. We're going to do a particles material and just use this. Okay, because now you can kind of see that there's something going on there. Trail. It's neat. Time randomness. Sure. I think that's a lifetime randomness. No, they're all going to live the same length of time. All right, emission shape. Oh, that's good. Okay, so now we have it in more places. If we look at the sky again, so view environment, okay, you can kind of see them if we get this over the dark section there. All right, so X in this case, if we go to the front view, can't see them. X, we want this to be 10. Is that right? Is that too far? Actually, I think that's too far. So it must be 5. Okay. Direction. That seems all right. Gravity, yes, we do have gravity. Initial velocity. So if we wanted to go poof, we could rotate this. Make a little cannon for it. Whoa. Front view. Which direction are they shooting? They just keep going up. Where's gravity? Okay. Hey, Brooke. Thank you for the raid. How you doing today? Well, good morning, everyone. About vampire stream. You've fallen into my trap. Welcome. Yes. Velocity random. Radial acceleration? See, I want these rotating so we can see them from other angles. We're creating little things here. There's my face. I'm up here. I'm up here. Ooh, rapier 2D. Yes. That sounds pretty cool. Doing stuff with a rapier like that? Yeah. Oh, you got a circle to balance on a pin. What? How? Rapier can do that? I mean, jitter and most physics engines just won't let you do that at all. So that's surprising. We're looking for tangential? I want to see these things. Rotating. Oh, that's no, it's tangents. Angle? They're not spinning. I want them to spin. He didn't give the platform any size. Wow. Wow, that's cool. That's really cool. I know. What is my shape? I made the shape the wrong type, didn't we? Didn't I? I don't want to blame you for this. Draw passes. Plane mesh. What if we switch that to a quad mesh? Size 1:1. Can we see it anywhere? Oh, there it is. Oh, it's on the back side. Oh, front view. Well, that's not good. We can't see it. Okay, this thing, let's transform it. Spin it on the Y, 180. There we go. Now we see that. It's a lot of defaults. Well, happy Friday, everyone, and welcome. And I am on Starlink. It's been getting better every month, so if we have a little hiccup here, just bear with it. I dropped my bandwidth, so my bandwidth usage, hopefully that improves it. I'm checking on it right now on my phone. It looks like we got clear skies for a moment. So let's see how it goes. Okay. Now I want these things to flip and rotate and do all sorts of things. So we have that. Let's move the bounding box up a bit later. We'll do that later. Okay, close the draw process, close geometry. Okay. So if we change this, they go in different directions. It's kind of cool. What do I prefer working with, Godot or Rust? Both, actually. I like Rust as a programming language more so than I like GDScript. You'll see it when I get into GDScript. I'll write some code, and then I'll have to run it to see is it correct. I don't like doing that. But I like Godot in that it's had time on machines, right? It's an engine that is used. It's got a fantastic license. So the rendering engine, like just the game engine itself, is, how do you put a value to time on hardware? Fixing random Android bugs for the next big Android phone that comes out, or getting it to work on Metal, etc. There's a lot of effort, and there's a decent community around this, more so than, dare I say, Bevy or some of the other rendering engines, or even like if you want to get this platform compatible with like Windows. I'm on a Mac. It's out of the box here. So I really, really like that. And so I'm willing to, put up with some of the how like Rust and their C++ engine don't always match up in order to get that mature engine. As as a experienced software developer, there's a lot that you can't really put a value on, like having a decent sized community and having bugs fixed for random OSs, etc. Yeah. You solve it by never deploying projects outside of your computer. That's one way of doing it. Yeah. Oh, look, those are going front and back in every direction. I hadn't realized that. You use the same strategy? Oh dear. There. See, and these are 2D ones. Definitely want the 3D one. Back. Where to go? Particles. All right. But I don't want that. I want them to spin. Dampening. Scale. Sure, let's have random scale for these. Whoa. That's neat. So we do like 0.5. We get some things that are different sizes. GDScript doesn't do a compile time compared to Rust. My favorite is this. Let's say I'm referencing something in the scene tree. If I go like this and save it, good luck. That doesn't exist. So, now, granted, in Rust, there would be no way to, you know, in Rust, you would basically have the same problem. But Godot actually has the information available. And it isn't. I don't understand why it's not. All right, we're going to skip this one. The ways that I love you. Can't stop. Can't stop. Going back to 3D. All right, so let's... How do we get this to randomly rotate? That's all I want. Random rotation. Gravity? Gravity's working. Direction. Spread and flatness. Okay, flatness 1. Okay, can we take... What if we take flatness to 0? What's that do? Amount of spread in the YZ plane. The value of 1 restricts particles to XZ. Oh, I see. So in this case, I don't know, it kind of looked the same, didn't it? I didn't notice a difference. No idea. Okay. I don't think this is doing anything. These things here. Oh well. Initial velocity. I could say that they're going like 10. Random velocity? Sure. I kind of like this one better. Yeah, but that's not getting them to spin. Angular velocity. Are they rotating? No. This is so messed up. Linear acceleration. And now they're just hovering. Radial acceleration. Ooh, that's kind of neat. But no, not what we want. It goes side to side. What I'm trying to do is get it from like just moving up and down like this to getting it to spin. I want it to spin. But everything seems to want to stay on that axis. Maybe it's because our material is still, our shape is wrong. That's not it. Where is it? Ooh. All right, well, we're going to time box this another 5 minutes or so. and then we'll get on to doing serverless. Yeah, if it compiles, it works. I miss that when I do GD script. Draw passes. Let's change this to a box. Cube mesh. Okay, now we have our cubes. Welcome, glitter. Size 0.5. Okay, great. Or just one. Okay, now let's see if those can rotate. Okay, no random scale. Nope, not that. Dampening, no. Tangential. I think that's going to make it go side to side. Yeah. Nope, not that. Radial. Ooh, it's kind of fun. So you could have basically like negative radial. Things coming into the center. That is neat. Okay, linear. Okay, they're basically accelerating down again. Velocity randomness. Initial velocity. Yeah. Oh. Oh. Disable Z. Okay, they're all in the same line, same plane now. Align Y? What's this one do? Sure. Rotate Z. So if we go back to the front view, can we now? Is it? Just do a bunch of these. Kind of spinning out. All right. Not what we want though. Radial. Whoa. Let's just say one. -1? That is crazy. Well, let's just make something fun. That is crazy. Okay. 0? Go back to 0 for that, please. Thank you. Oh. Okay, so what we're going to do here, let's change the shape to be a sphere. Okay, we're going to turn off gravity. Going to be 0. So they just sit in place. Great. Okay, now orbit velocity, let's set you to 1. Let's change the size of this. We've played around with this long enough. Draw passes 1, 5, 5, 5. There we go. Color. I want random colors here. Hue variation. Can I say, let's take this all the way up. Sure. Oh, it's 1 to -1. Oh. We're not really getting much hue change there. We do want a random scale too. Whoa. Oh, that looks cool. Now, orbital velocity, I want to slow it down some. Do 0.5. Okay. Velocity random. Some moving faster than others. Radial acceleration. Oh, let's leave those alone. See, if true, particles rotate around y-axis by angle. And we were changing angular velocity. They're not doing that. Okay. Let's put that back. Align Y. Oh. Oh, that's cool. We're working on our, hey, there's a new follower sort of animation. So if we do this, like this, Godot starts up. Okay, so it needs to be quite a bit larger. Okay, particles. You need emitting on amount 100. See, it's way too big. But our bounding box needs to be much larger. Particles generate. See, it's way too small. Oh, the sphere radius. The radius should be 5. There we go. This is gonna be crazy on the compression. I have a bad feeling about this. All right, needs to be bigger. Sphere 10. Oh, that's all right. Okay, even though the color's not there, that's it. We're done for today. I'm gonna save that. Oh, particle generate AABB. Restart it. There we go. So now I would like to fade this in, but we're out of time for that. We'll just save that. Project. Whoa, cancel. Project. What did I click on? Oh, install Android build template. No. Click there. Export. Not debug. Save it. I don't remember if I put it before or after the other thing. Hopefully we can still read the text. Spider-Man, yes, we're hanging on. All right. Now I'm on the other box. I'm gonna copy it over. Actually, I'm gonna do this off screen. So just bear with me. Where's Finder? Okay, there's Finder. I need to close down Mitch. Good night, Mitch. Oh. There we go. Now it's copied. Almost there. Okay. Start up Mitch again. Okay, Mitch is running. Oh, and thank you. Volcanic Popsicle for the follow. All right, now we're gonna test that. I'm gonna shave the beard. Just trimmed it. Really, I didn't get a razor. I just take the hedge trimmers to it. But yeah, it's gone. Where's Firefox? Oh, there it is. All right, we're gonna test this real quick. Got my mule. Evil Halsey. Evil Halsey is gonna follow. Let's see what it looks like. Then I'm gonna try to track and see how many frames we actually lose to this. Okay, I'm gonna put that in full screen. I want to see this in full screen over there. Okay, that's pretty good. We're gonna click on follow. I sense a new presence among us. Where's the I'll get back to that another day. Good try. Good try. All right. So we were working on mimeograph, which we are calling a serverless website builder. I think, you know, what are those other sort of off-the-shelf website builders that people use? Let's see, is this, that's all the way up, right? Yep, good. Okay. Sorry, the music was too loud for me. So what we're going to do in here is try to get something so that we can edit it and save it. We should know based on our permissions, which don't exist yet, whether or not we have access to edit something. Okay. Maybe we should do permissions first, huh? Because I'm pretty sure anybody can go to this. You guys, all y'all can do this, right? You can, this isn't like a secret thing. So maybe we do permissions first. So maybe we'll come up with like /admin. Oh, you know, we gotta get the, we can't even do that yet. We can't even route. So, good night. And we pull a request handler out of the Rust compiled into WASM code. So here's our WASM bind gen. Where does this come from? Worker? No. Huh. WASM? Where do you come from? Is this all compiled into the same JavaScript file at the very end? They're just using globals here? Ah, body part script, bindings, WASM module. Belginal, good morning. Yeah, okay, it works for you. Yeah. So we should start with permissions right out the gate then. But in order to do that, we have to get routing working. All right. So to get routing working, what's it say? Fetch and log a request. Great. Yeah, we know. So add event listener to fetch. Oh, that's right. There are different sorts of events that we can attach to. But instead of us parsing the request string here and figuring out which handler we want to use, let's try to pass in the handler into the Rust code so we can parse it there. Now, does anybody know of any like off-the-shelf JavaScript and Godot? We just switched. Sorry, I probably wasn't all that obvious. I was doing a little stream warm up, trying to work on the glitter tools a little bit every day. Um, so we did that. We tried to add that little cool particle effect. Didn't work. Well, it looked like it worked. Just it didn't compile completely or something. I don't know. Getting stabbed in my foot. That was in my shoe. All right. So now we're actually switching gears, a little slower this time, and we're working on something we're calling mimeograph. And mimeograph is a serverless website builder. So we're going to use Cloudflare, durable objects, key value store, and build a website builder tool. Think what is it? That website generator tool. What is it? Not like the static one, but like WordPress. Think WordPress. Oh, it's telling me not to cry. All right. So next step here is to get the request handler accepting this request object, which isn't going to work right now. Cloudflare has this tool called Wrangler. We're going to use that. Oh, where are you? I'm thinking about it. You probably could use JavaScript and Godot together. You would have to use like V8 or something like that and build a bridge using GD native, and then somehow deal with the ability for scene graph elements to just go away. Right? So you're gonna have to have some sort of wrapper around those in JavaScript that was okay with them vanishing. Okay. Now, if we load this up, okay, great. It didn't crash. Okay. However, we need to parse this. Now where? There's so much info in here. This is neat. Client handshake, time zone, gzip, colo, SJCSS San Jose, fetcher, headers. Oh, region Idaho, core line. That's interesting. think, I think Starlink has a ground station near there. I wonder if that'll change depending on the satellites. All right. Oh, I didn't mean to close out. Let's leave that in there. I'm going to create in our lib a request object, and hopefully we can accept a request object. Struct request. Oh, that's not it. Okay. What do we have in here? Okay. Oh, just gonna replace all the commas with this. Okay. Let's see if we can organize this just a bit. So we got this CF. Who knows what that is? So maybe we're gonna have multiple elements here. TLS client auth. Okay, those all go in the same one. This could be its own structure here. Got some more values. TLS exported authenticator. Interesting. Client TCP round trip time. Okay. Ah, look at that. Okay. We have body. Body's null, so we didn't get a post. Okay. Let's call it a CF request. There's a third-party solution for using TypeScript with Godot. Very likely. There's a whole bunch of them. You can use like oh goodness, C, C++, NIM, all D. GD native. Yeah. I don't think this has a big list. No. What else? I don't see it, but there is a list here somewhere. Why the CF? We can probably serialize that out. And in this case, this request was an object. Do we really want to serialize it to be able to pass it through? Probably not. So how do we get this set up? Let's go look at WASM, bindgen. Example. WASM bindgen futures. API docs. Let's start there. Ooh, representation of an object owned by JavaScript. JS value. Can we just accept that? If it's an object, can we do anything with it? Can we inspect its properties? Can we get strings? Only cliches. Good morning. Good morning. How are you doing? From Saturday into Saturday. Creates a new JSON value from the JSON serialization of the object T provided. Into Saturday. Yeah, see, I don't really want to stringify it just to give it to JavaScript. Just give it to Rust. Oh, what is this? Impl from WASM ABI for JS value. What are we trying to do? We are trying, okay. So welcome, and we are currently using Cloudflare's Wrangler, etc. And what we're going to do is take the request that it receives and try to pass it into Rust. So let's pull up the code. So here is the JavaScript side. We get this request, right? So we tell Cloudflare, we're listening for the fetch event. We're going to respond with handle request. Handle request is given this event. I think you're right, yeah. Twitly doof. Good morning. What's up, Batman? Not too much, man. Not too much. Okay. So, I see the problem. It's that line right there. Oh, yeah, that one. Yeah, so we can get WASM inside of the Cloudflare worker, just working perfectly, right? But this event that's coming in, I would rather have I guess less going on here. I don't want to set up a router here, right? Like if route dot contains blah blah blah, you know, do WASM dot handle foobar, right? That I don't want to do. I want to do that. So I was trying to just pass more of this from JavaScript into Rust and handle more of it inside of Rust. Now we could do the JSON. It'd be kind of a one-time hit, right? Handle request, give it the whole event, just give it the whole thing, pass it through, stringify it, take it back out, and go. Limited by the runtime provided by Cloudflare. Yeah, it's I think it's, well, okay. And as a string, I don't think so. Because here, this request, when we dumped it out, had quite a bit to it. Let's actually get the whole event. Let's say handle fetch. All right, so now we have event piped through. Here we're just going to stringify it out. Wrangler. Oh yeah. I butchered some stuff in here. Let's comment that out for a moment. I like that it works pretty well. Like that little, it's like a second and a half. It's pretty quick. And does this actually work? Okay, let me try again. Just a minute. I want to try it without, because I don't know if it's. I'll show it if it's good. Oh, what in the world? Okay. So that is it. This is the whole thing. That doesn't seem right though. Because we should be console logging that. Here. That. We don't even see that. Try again. Yeah, like, and that's just a logging. I think the dev Wrangler thing, it automatically logs the requests. There we go. There's a little bit more. So yeah, here's request, and here's the CF that we saw before. And it looks like, yeah, we just have type and fetch outside of it. Okay, so we didn't actually lose much here. Now, we did see, what was it? In here, what is this? From WASM ABI. Because we end up being in the same VM, right? I know the VM basically has the WASM stack, and then it's got the other pieces, right? It's got the traditional JavaScript world. So inside of V8, I presume they're running this inside of V8 for their workers. We should be able to inspect each other. I mean, or is that just not true? So yeah, we have a JS value. We can see, is it an object? As ref. Not really? Oh, that's too bad. Okay. Oh, what is JS cast? Unchecked from JavaScript? Huh. Oh, what is this? Dynamic cast checked at runtime of this value into the target type. You can have a shared array buffer. Sure. That makes sense. This is interesting, though, this JS cast. A trait for checked and unchecked casting between JS types. Specified in an RFC. Okay. This trait is intended to provide support for casting JS values between different types of one another. In JS, there aren't many static types, but we've ascribed JS values with static types in Rust. Oh, this trait is automatically implemented for any type imported with the WASM bindgen extern block. Interesting. So maybe we could create this type? I mean, this looks like it might do it. But then we'd have to implement this for that type. Instance of unchecked from JS and unchecked from JS ref. What is that? One of our neighbors' horses, flies, giant fly. Okay, so we could just pass that through as some sort of string, right? Squirrel. Oh, no code. Right, that should have worked. DT to right paren. Huh. How's it hanging? It's hanging all right, man. That's doing all right. So here we have request handler. Let's rename this to fetch handler. All right, now go back into here. Was I muted? Oh, I'm so sorry. Yes. I really like the idea. The Starlag one? Yeah. Actually, I need to help out for just a minute. Drat. Okay, well, give me a couple minutes. I gotta help move some stuff. Should be less than 10. Maybe. Maybe not. Pour some tea. How's your week? Keep having bugs coming out of this release. Time zone related stuff. Just so tired of time zone related stuff. And then part of the UI is in one time zone, and then the other part of the UI is in like local time zone. Yeah. Can you hear me? Can you hear me? It has ended, yes. Oh, that's rough. Good luck with time zones. Need a better UI. Like I find it confusing, the UI and the way that we're expressing time zones. It's not ready yet. Yeah, see, this isn't the same thing. Manually drop. Unstable APIs. Function overloads. Huh. Cargo features. Inheritance. Oh, that's for WebSys. I mean, can we export a type from Rust and then fill it in on the other side? Morning, Jeremy. Ah, now that there's one on Mars, it's going to get worse. So we should be able to set these up. So should we just export one of our own types? And instead of doing a JSON serialization and deserialization, we can better convert that. Just copy everything from one type to the other. I sense a new presence among us. Oh, Janie, thanks for the follow. Look at that. It worked. It worked. So a lot of these are just going to be strings. All right, so what types do we have? And we saw that there was even a little bit more in here, the CF request. That thing is flying around. I want to kill it. It's distracting me. I will be right back. Just really right back. Just a glancing blow. I don't think I killed it. All right. So, okay, so we have request CF. I don't think type is fetch here. Okay. Do we really have to do this whole thing? What other types do they have? We don't know. I'm being measured. That does happen from time to time. I don't know. This doing that seems like constructor, getter, setter, set field get. Oh, and you can configure the name. Now, what if we can they just create a setter and getter for the fields? I mean, that seems like a lot of boilerplate. Iterating over JS values? What? What is this? Interesting. Using fetch. So a lot of these types have already been kind of created in JSS, right? So, okay, let's come back in here. CF request. All right, so we have one of these, right? Now in this case, let's see, maybe it should be an event. We can have a type on there for fetch. Oh, interesting. Yes, we do need to rename that. Interesting. All right. You know what? I'm like this close to just using the JSON bits. I know JSON stuff is just so slow. On JavaScript imports, JavaScript functions and classes imported with Rust. Okay. Into Rust with an extra in C block. Catch. Type Zoidberg. Huh. Constructor. So we can construct JS types. And we can get a type back for shoes. But what is this shoes? How do we define shoes? Can we say that foo has certain properties? Interesting. Extends. Attribute can be used to say that an imported type extends another type. Oh, I see. In the JavaScript class hierarchy. Yeah, so prototype inheritance. Interesting that they use type here. Type. Extends foo. Feels very much like what GD native does. If that's code. Getter and setter. These two attributes can be combined with methods to indicate that this is a getter or setter method. A getter tagged function by default accesses the JavaScript property with the same name as the getter function. Consider the following JavaScript class that has getter and setter for the White Russians property. The dude, White Russians, getter and setter. Okay, yes, we have getter and setter there. Here we're importing the dude type and defining the ability to access each object's property. So do I always follow a top-down approach? I follow you. Where are the member lakes? Joker. Where are they? What? I don't follow, man. The pawns. Where? You got me on this one. I don't. Gotta explain that one to me. All right. Final. The final attribute is the converse of structural attribute. Wait, how did we? They're talking about. Okay. Function imported by final never changes after it was imported. Okay. Whereas a function imported by default or with structural is subject to runtime lookup rules, such as walking the prototype chain of an object. That's fair. So yeah. So everything that we're going to be using should be final. Actually, if anything is ever modifying the prototype chain, they're doing bad JavaScript. You don't want to change prototype chains a runtime. That's just bad. The eventual performance aspect of this aspect is that with the host bindings proposal, then WASM bindgen will need to generate far fewer JS struct shims to import than it does today. For example, consider this import. Hmm. All right, continue. Oh, index getter. Oh, interesting. This is like the proxy stuff in JavaScript. Oh, my mouse is working just fine, man. Skill point 90. Yes, name blah. Namespace. Okay. Method, module, raw module, static method of structural. We saw that. Hmm. So you can interact with JavaScript functions just fine, JavaScript functions on JavaScript types just fine, but you cannot inspect a JavaScript object. You can't just have a plain old JavaScript object. That is upsetting. Pulling it into my brain. That's right. Come to me, knowledge. You are mine now. Supported types. String enum. Oh, that's neat. Some JS type. Return imported type. Some JS type. They don't actually define some JS type, do they? Just that it's some type somewhere. Wait, how is that different than this one? Exported, imported extern, whatever. JavaScript type. Exported struct, whatever. Oh, I see. Where are we in this list? I have no idea. What if we do something tricky, like have a JavaScript do the prototype chain craziness? JS value. Yeah, that's not all that helpful. Box JS value. Take a pointer by value. Okay. Numbers, bool, char, stir, string. Yeah, all this is fine. Result. Hold on a sec. All right. All right. And this is where we had been. So given that, let's just do it. Let's see. So if we had a CF event, please stop. Please. It's changing my chairs and stuff. It's not cool. All right. Now we need the attribute on Rust exports. JS name equals blah. See, that's for something else. We want it on. Yeah, I don't really want getters and setters defined here. But it looks like you can really only do stuff with functions between the two. Like you can call a function, return some sort of base type. Oh, and this can be read only. All right. Getter and setter. That's fine. I wanted to change the name though. Let's see if we can do that. What does serverless actually mean? He doesn't define it. That means that basically somebody else is managing the server for you. An event happens. The event is mapped somewhere. So the event has rules which you define. And those rules say when this event happens, in my case, fire up this code, however you do that, fire up this code, feed it the event, let it return a response, and then shut down the server, right? And only charge me for the milliseconds that it ran. That's serverless. Event, machine, handled, event, returned response, done. And that's very simplistic, but one. Rename this one? That's for the whole thing. No. Let's do something just to see if this would work. So in this case, we want request and then type. What is request? Request is some big object, right? Yes. We'll say that request is just some string for now. Type is also that. That's reserve word, so we'll just call it tie for there. Now we will impulse cf event. Mostly stateless? Because depending on if you have enough events, you might be able to actually hold on to things like a database pool. Like in AWS, you can do this. So you don't have to reestablish the connection to the database every time. So, yeah. But yeah, you should think of it as stateless. Absolutely stateless. And then when you're like, oh, it's slow, then somebody will come along and tell you. All right, so CF event. Where's our getters and setters? Exports here. So wait, why hasn't bind that as well? I sense a new presence among us. Al Hansen, thank you for the follow. All right, so at this point, we can say this is a constructor. Interesting. Wait, I have to provide all the fields. Oh, that'd be sadness. Okay. I think what we have to do is kind of define the leaf nodes first. Okay, so there's our CF event. That's the outer thing here. Then we have our CF, what do they call it, a request? Where'd it go? Here. So this is our request. And request has this inside of it, which we already have defined. And let's have an enum pub. Do these have to be pub? Probably. Event kind. All we know is that we have one currently, which is fetch. Type fetch. Looks like it should work. Oh, JS says cargo add. Yes. What features first? Okay. Cargo add JS says. That should be a request. All right. Let's create one of these. And why are some of these? I don't even know what the types are here. They all look like strings. Everything in there. Oh, we're inside the impl for. Oh. I did that wrong. That's the impl. Wasm bind gen. Oh, struct. CF request. Okay. Um. Sorry, I have to look up a Slack amount. Oh, we have so many. I need one for this work thing real quick. Just a moment. There we go. All right. I think we can omit this CF section because it doesn't seem to have anything extra. Oh, maybe it does. No, it does. It's got CF is this. Actually, I'm confused. Are we missing a property here? CF, and then it just starts with key value pairs, and that goes stops here. So OCF is Cloudflare bits. Then we have the rest of the request here. Oh, I see. Okay. CF. Don't know. Just gonna call it CF for now. Struct CF. Okay. And then what do we have here? CF then those. What do we see here? Let's convert this. A fetcher? I don't even know what's a fetcher gonna be. Oh, something that we use for making requests. Ooh. Okay. So that's an object? Headers are empty. Method get, body used, false, body. Oh, whether or not the body is used in this request. Okay. So let's say that's a string. I have no clue. If that's a string, it says it's null. That's a bool. This will be a string. URL string headers. And what do we think this is? Let's say it's just unit for now. And let's put some commas at the end of those lines. There we go. We have our CF request. CF has one of those, etc. Let's not copy. CF request isn't. Does it? It needs to be copied to be WASM bindgen. That's interesting. Can we instead use lifetimes here? Because CF request will never be copy if it has strings in it. Can we keep a reference to a JS string? Supported types. Okay, so we could have a reference to it. Okay. Can we do that? WASM bindgen. You have to own that, which means we're not copy. Wow. This went sideways quick. What this means then, okay, if this is not pub, we can have that. Which means that we have to actually return one of those from a function, like a getter. So we could copy it and return it. Okay, that's fine. Because we do not intend JavaScript to actually... Oh, actually we could, couldn't we? So in this case, pub. Yeah, that's not marked copy. All right, let's impl CF request. WASM bindgen. Now let's create our exports. Constructor. Pass it all in the constructor. Oi. We could. Pub function new. Actually, generate new. There we go. All right. From WASM API. That's fine. All right, let's say that our fetcher is a string for now. Or how about an int? I32. All right. Oh, it's not implemented for CF. CF? Yes. Yes. We don't know what CF is. Just some random object. Okay. And what is fetcher and headers? I mean, I'm going to make that an I32 anyways, so we don't have to worry about that at the moment. Okay. Now we have this CF request. Got a CF event. Let's create a new for that. Generate new. Fine. Can I do like a pub create on this and not? Okay. Yeah, we could. All right. Just checking to see if it still needed to be copy. If it was pub create as opposed to, let's say, just pub. Because if we do pub, then it's going to tell us it needs to be copy. It's not copy. But if we do pub create, we're okay. So, all right, now CF event. Let's make those pub create. Or if there's a way not to export them. Supported types, attributes, on Rust exports. Oh, no, I meant to click. Yes, that. Read only. Interesting. So what if we did read only on this? Does it still need to be copy? Yeah, it does. Yeah. So event kind is here, and that's fine. Fancy. Okay. And in this case, we'll take a CF event. BBG event. What? Oh, it doesn't implement debug. Let's do that. There. CF request. And event kind. It wants to be before the derive. That's fine. All right. Now we have just a couple values here that we're going to toss into the constructor. Go to worker. Now, how do we use this exported type? Supported browsers. Interesting. I didn't see that before. Huh. Edge, Big Int, and use 64. Okay. Where else? So is this actually still in? This initializes it, right? This is destructuring it. So we should just call it a fetch handler. Do we have to pull the types out here as well? It's example. Example. No, that, okay, we could look at the GL example. WebSockets example. Define a start. I don't see types getting exported there. WebSockets. Nope. What is this one? WebRTC. See, I don't see JavaScript code, actually. We're just using start. Say here. Yeah, we could do that, but I don't think, no, we can't, can we? Because worker.js is going to be called. Rust, WASM, export type, example. Exported Rust types. Oh, WASM by example? Oh, look at that. WASM and net. Call me from JavaScript. Okay. Examples, okay. Exporting JavaScript functions? No. what? Exports. We just looked at this. But these are like constants. And that's not helpful at all. What? Alright, so let's go back a ways. And where's that actually coming from? So we can import these from that, which is very similar to this WASM bind gen. Looks like it's being deconstructed. This, I don't know what this does. All right, so how about we also pull in the type here? And what was our type? It was CF event, CF request, CF event kind. So now we will just pass in down here. Okay. Const CF request. Oh. Got to do this in JavaScript. Okay. New CF request. Const event kind. Actually, that's all rusty, isn't it? Dot request. How do you use an enum defined in Rust in JavaScript? No idea. Okay. Const C. Let's say this is the event. Request and event kind. Look at that. I'm getting my casing all messed up. Okay. Yeah. Abbreviation substitution coercion. CRU, CRD, CR dot case big case. CRC. Okay. Oh, so much better. All right. This is going to break. It's wrong. But I want to see it run. Okay, we got to make that emoticon eventually, or I need to do something mechanical, like when I mute myself, pull the mic away, and then when I pull it back, I need to make sure I unmute. I think I'm gonna start doing that, and hopefully we can snip that in the tail there. But yeah, I was thinking, I'm glad you enjoy the streams. I really don't think I would have made it this far learning Rust without streaming on Twitch. Started September 12th, and what year is this? It's 2021, 2019, September 12th, 2019. Streamed over, I don't know, 1,600 hours. Actually, let's look that up. Where are we at currently? No, not 16. We are at 1,550 and a half. So it's been a lot of practice with Rust. A lot of practice. Still. Yeah, and at the beginning, I knew nothing of Rust. Just liked what it had on the box. So CF Request is still bailing on us. Okay. What do you think it is? Is it body? Here, what's going on in here? Fetcher. Redirect as manual. Headers. Okay, that's 0. URL. Fine. Method. Fine. Body used false. That should be good too. Oh, but body is null. Yep, that's all on my free time. I don't do it for work. I have tried to get them to use Rust at work. Like, we could spend so much less money, but no. So I think we could actually have quite a fewer machines on the back end. They're running Rails, and I would love it if we could actually run some, at least the CPU hungry stuff. Run the CPU hungry stuff on Rust. Traditionally, it's been a Rails shop, and I get that. And getting somebody else to like let's say you have a bus factor, right? You get hit by a bus. Who's going to come in and fix it or add the next feature? The Rails guy? Probably not. Nothing against Rails guys, but you're not a Rust guy. So Rust coder. I think guy in the gender neutral form. Is there a gender neutral guys plural? I don't know. Like, how do you say that? Y'all is neutral. All y'all. Just go southern on you. Going from Rails to Rust is quite a step. Yes, it is. It's an amazing step. However, one of the other backend engineers I have learning Rust. So there might be hope. IntelliJ does support Rust, right? Folks, people, yeah. All y'all, all y'all backend devs, all y'all Rubyists. Functional. I have to agree. Only cliches. I think that like once you're done with Rust, like your total end to end is faster. And the functional programming, that'd be fun. That would be really cool. Scala workshops. Yes. Erlang. Go Elixir. Elixir. It's my favorite. Of like Erlang, Elixir, or what's that other one? They have Lisp flavored Erlang. Yeah. Scala's pretty. Never seen it. Oh, did it die? Or did I kill it? All right. Could not read property length of undefined. Thank you. Pass string to WASM. What can I do? So I could check the logs, but that's not going to be helpful. That's exactly what I have here, I think. Yeah. Any extra work you do after the production release, it's extra money your company is cashing in on for maintenance. You're working contracting. Yeah, and you do get paid for that. I'm guessing that it's this body piece. Okay. We need to have a better exploration here. Let's say that this is I-32 and body is set to none here. Just want to see if that's it. Because if it's one of the others, goodness, it's going to be a problem. Wow, that was done so fast. Still an error. Still the property length. Not read property length of undefined. Is that because the one of these strings is undefined? Body is null, yes. Get, that's something. Redirect, set to manual. And then from here to here is, we're just treating it as a number. Internal server error. Okay. Pass string to WASM. Length of undefined. Okay, so it's pass string to WASM. Worker, did I get one of these wrong? Redirect, URL, method, body used. Okay, let's check the order. CF Fletcher, okay. Yeah, that one's good. Headers, empty, yes. URL, method, body used, and I-32. Let's just pass in 0 there. That's so fast. Oh, that's so nice. Okay, still same issue. Body used should be a Boolean. Yeah, that's false. Then it's not complaining about passing a bool. So which one could it be? URL, so redirect, URL, and method. Redirect URL and method. Is that supposed to be like a JS string or something? Is there such a thing? Take string by value. Yes. Take option string. Oh, you can pass in null or undefined. Okay, that's perfect. But still, our strings are not the right kind, are they? Is it just because it is serializing them for the JSON? And that one of these types is not the type we think it is? Yeah. Oh, that's right. We have the JS string still. I'm guessing it's the URL. What do you think? URL? Which one is not the type? Thanks. Let's see something. Where's the rest of our stuff? Did it not actually? Is it only redoing JavaScript? Like we've been making all these changes and it's only redoing the JavaScript? Hold on. If I make a change here, so I save that, it detected changes. Compile, checking for the WASM target, compiling to WASM. That seems decent. It's looking at that. Reload, unable to connect. Oh, unable to connect. Why? Oh, was I just too quick on the draw there? Yeah. Okay. Oh, they're all undefined. Well, there's your problem. Because it should be event.request. We stepped into JavaScript for 20 minutes, long enough to get tossed into the glass there. That's just checked us. Man. And I read property request of undefined event defined. Oh, I did the wrong ones. Okay. Detecting changes. Good. Done. String, 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 Boolean. Fantastic. So those are strings, but I just had to provide the correct string. Redirect URL method body used. Okay. Okay, now that we've fixed that, Rust wouldn't have let us do that. I would rather fight the compiler than fight the anonymous error. Right? Fight the darkness. Halsey fires magic missile into the darkness. Did we get it? I don't know. Is it still there? We don't know. Will Halsey survive the battle with JavaScript? Find out next time. All right. I got about 10 more minutes and I gotta go. Okay, but we did get closer there. And what is the next error? Okay. You're eaten by a grue. Uncaught. Cannot read property request of undefined. Where are we trying to do that? Here. This. So we actually created the object there. Fantastic. See, this is an enum, and I don't know how enums are actually exposed. Search for enum. Oh, spawn gen. Yes, yes. Great. We have a public struct here. But how do we construct that? I don't see the enum actually being used in here. Is it just a string? Okay, it's just a string. In that case, we should be able to say event.type. Wow. Emil, how you doing? How are you? Oh, wrong one. I lost the window. Where is it? Is it that one? Yeah, that's that one. Still an error. Ooh, no pointer passed to Rust. Fantastic. Where? What you working on? We are working on a website builder using WASM and Cloudflare's workers. So kind of serverless website builder. All right. So null pointer was passed to Rust. Which one was null? Event.type? Type should have been fetch. Body is null, but we're not passing body in. What else could it be? Fetch handler, CF event. I mean, it could be a CF event. Maybe this isn't created correctly. I sense a new presence among us. Abros77, thank you for the follow. let's delete that. I could see debug becoming useful. Like which line did we hit? Yeah, we got pub sub working correctly. We got that going. We did actually use I don't know. We warmed up today working on our stream effects. Oh, the can only use in TypeScript files. Um, of course, that's not Rust code. That's JavaScript code on the left. uh, a okay. Which one do we hit? Oh, it aborted. Apparently, it's in TypeScript. But, or at least that's what the editor told us. Let's come back here. Reload that. Oh, we got two A's. And then an error. So null pointer happens after two A's. Here in fetch handler, CF event. Oh. Wait. CF event itself is null? Or did I just do like a misspelling? No, it's still there. Okay. CF event. That looks good. Yeah, we'll save that. Reload. Okay. It's not null. That's what we care about. But this fetch handler, we're not getting the debug here. That doesn't look like a null value to me. It looks like an object. Null pointer passed to Rust. Huh. Fetch handler, anonymous WASM function. I really am trying hard not to write JavaScript on stream. You know, it's JavaScript has provided well for us. Spot the null. I don't see it. Unless, I mean, it could it be CF event somehow? The CF event is just a pass through. It just holds on to those. Why is there so much backlash in JS? Um, I think it's less backlash and more I prefer Rust in this case. I mean, I'll go from this and write 8 hours of JavaScript after the stream. So maybe it's just I don't know. Like the error earlier, right? Okay. We had forgotten to have the request there. And guess what happens? We spent 20, 30 minutes on this. Cannot read property length of undefined. Something's undefined. It won't tell us what. We have no idea what's undefined in this case. So we actually had to go through and do a lot of debugging in order to figure out what it is. So there is no dot length in our code. Yeah. I mean, JavaScript's a fine language. I think it's definitely got its place. But I prefer Rust. I do. For exactly that reason, that it was hard to debug, it was complicated, the tooling wasn't helping us. And this happens also, like if you're trying to debug something in minified JavaScript code, like, oh, we've got a bug that only happens in production. Hmm. Oh, I'm just a hater. Oh, fine. JavaScript hater. Halsey. C. Kane, good morning. I have to say, I prefer TypeScript over just vanilla JavaScript. I really do. Because it's got a little bit more of a layer and it will tell you that, you're trying to use, URL and this type doesn't have URL. Like those little pieces there, just that little bit of help that the compiler can give you is amazing. It is so, so nice. And it saves you so much time. I know they're like, I'm just not a JavaScript purist, right? The sort that's like, oh no, you should never do um type checking. That is against JavaScript. Oh, okay. Rust and Elm spoiled you too much. All right, but now we have this fetch handler. Fetch handler. Got our little bind gen here for fetch handler. Got our CF event, which we should be able to bring in now. You use flow type for everything. You don't need compiler errors if you don't have a compiler. I don't mind actually writing vanilla JavaScript. Right? But as soon as you start to get into like using Babel, right? Because usually if I'm going to be writing vanilla JavaScript, I'm going to be doing things that are kind of like, I don't know, faster in JavaScript. Babel like bloats things, I don't know, what, 30% at least? Okay. I'm not seeing it here. He told me, and I don't know if it's a trustworthy birdie. Yeah, TypeScript used it from like 08.3 to 1 point something, 1.5, 1.5 something. I don't think I made it to 2. We might have. No, I remember sitting there for, oh goodness, it was a long day fixing all of the errors that the new compiler found. Because it was, yeah. All right. Null pointer passed to Rust. This is an unknown object. I'm fine with that. That's perfect. Unknown object. And then it dies here because a null pointer is passed to Rust. Where? Where is this null pointer being passed in? It must be on one of the previous types. Maybe CF request? What if instead we change this to CF request and passed in CF request instead? Oh, the defaults. Oh yeah, should definitely be strict. Oh yeah, all of. I agree. Wrong window. I think it's easier for people to kind of ease into it. Oh, look at that. It did it. Okay. So what's wrong with passing an event? Oh, no, CF event. We're passing a CF event. Is it event.type? Is that what's broken? Type should just be fetch. Unless it couldn't convert to that type. Yeah. Those defaults have to be so that people can ease into it. Because if you didn't have that, it'd be tough. I go from just like a JavaScript coder. All right, I think it has to do with the enumeration. All right. Enum. We've got this here. We've got string enum, and that's in this struct here. Which doesn't exist anywhere here. Pub string enum. A Rust.js transpiler? Like TypeScript on steroids? Huh. I mean, couldn't you do that with WASM? Because I know that you can build up a WASM library using Rust and then publish it to NPM. Yeah, I'm not seeing it. Enum. Okay. Exporting structs and enums. WASM bindgen. Choice example enum. Okay. But then in JavaScript, how do we call that? Oh, wasm.example.yes. Okay. Let's do that. Dot fetch. Yeah, we do have prettier. There we go. Formatted. All right, so cannot read property fetch of undefined. Uncaught in promise cannot read property fetch of undefined. The rest of our types are exported correctly. CF event kind. Undefined. Yeah, there's no pub on that. Strange. Why doesn't that work? This is basically what we're doing. We imported it, right? Have yes. Maybe. Let's restart it. I don't know. I'm suspicious of the tooling. Okay. Run it again. Same issue. Still undefined. Ew. It's a struct though. Verify. C styled. Okay. Oh, Starlag. Yes, we need another one. We need our emoticon. No audio. Oh. Refresh as always. Okay.